Welcome to our comprehensive lecture on the India State of Forest Report, or ISFR. Today, we are going to dive deep into how India monitors, assesses, and categorizes its vast forest resources. Let's start with the basics of the ISFR. Every 2 years, the Forest Survey of India conducts a massive assessment of the country's forest resources. This results in a biennial report. The tradition began back in 1987, and it has been a crucial environmental health check ever since. The 2021 report marked the 17th in this series, with the 2023 assessment slated for release in 2024. The organization behind this massive undertaking is the Forest Survey of India, or FSI. Established in 1981 and headquartered in Dehradun, the FSI operates as a premier national organization under the Ministry of Environment, Forest, and Climate Change. They are the primary authority on forest data in India. What exactly is the FSI tasked with doing? Their primary objective, of course, is to prepare the State of Forest report every 2 years. But beyond just writing the report, they conduct extensive inventory assessments. This means they are out there measuring and cataloging resources not just in dense forests, but in non-forest areas as well, building a massive, comprehensive database of the nation's ecological wealth. In addition to building databases, the FSI acts as the central nodal agency for collecting and sharing spatial data. They don't just keep this knowledge to themselves. They actively train forestry personnel across the country in advanced technologies like remote sensing and geographic information systems. Furthermore, they provide critical support to state and union territory forest departments to help them survey and map their local resources. To achieve these objectives, the FSI engages in several major activities. First, they conduct nationwide forest cover mapping using remote sensing technology on a 2-year cycle. Second, they maintain a continuous national forest inventory. And third, they play a vital role in forest fire monitoring, using satellite data to detect and track fires across the subcontinent to aid in rapid response. The FSI's work also extends into climate science. Their fourth major activity is forest carbon assessment, which is critical for understanding India's carbon sink capacity. Fifth, they conduct detailed forest type mapping to understand biodiversity distribution, and they take on specialized projects addressing emerging ecological issues, ensuring the country's forestry strategies adapt to new environmental challenges. Now, let's connect this national effort to global goals. Under the United Nations Framework Convention on Climate Change, or UNFCCC, there are specific guidelines for implementing REDD+. REDD+ stands for Reducing Emissions from Deforestation and Forest Degradation. To participate, every country is required to have a satellite-based national forest monitoring system and a national forest inventory. The primary objective of this intense monitoring system is to assess the growing stock of trees, which simply means calculating the total volume of all living trees in a given area. But it doesn't stop at timber. The inventory counts individual trees and bamboo, measures the carbon stored in the soil, catalogs non-timber forest products like medicinal plants, and even tracks the spread of harmful invasive species. This data directly feeds into tracking the United Nations Sustainable Development Goals. Take SDG 14, Life Below Water. You might wonder how forests relate to water. The answer is mangroves. The FSI tracks specific indicators for this goal, namely the percentage change in mangrove areas over both a 2-year cycle and on an annual basis, as these coastal forests are vital for marine ecosystems. Moving to SDG 15, Life on Land, the FSI's data is even more central. They monitor several key indicators here. Indicator 15.1.1 looks at the total forest area as a proportion of India's total landmass. They also track Indicator 15.1.2, which measures trees that exist outside traditional forest boundaries, and Indicator 15.2.1, which calculates the overall percentage change in forest area coverage over time. The monitoring for SDG 15 continues with a focus on restoration and expansion. Indicator 15.23 measures the total tree cover successfully grown outside designated forest areas. Indicator 15.32 is crucial, as it tracks the success of increasing tree cover in previously degraded lands. Finally, Indicator 15.41 specifically looks at the increase of vegetative cover in fragile mountain ecosystems. To truly understand the ISFR, we need to understand its terminology. A major term you will encounter is Recorded Forest Area, or RFA. RFA refers strictly to the extent of a forest based on its legal status, not necessarily what it looks like from the sky. It primarily consists of reserved forests and protected forests that have been legally constituted under the Indian Forest Act of 1927 or similar state-level acts. This brings us to a very important distinction. The term RFA is applied to all lands that have been officially notified as a forest under a government act or simply recorded as forest in government revenue records. Because this is a purely legal and administrative classification, a recorded forest area may or may not actually have any physical trees or forest cover on it. So who decides what gets recorded as an RFA? That power lies with the states. State forest departments are the legal custodians of these areas, and the FSI relies on them to provide the boundary data. Since a landmark ruling in 1996, states have had the freedom and prerogative to define which tracts of land qualify as RFA. The Central Forest Advisory Committee has even affirmed that criteria finalized by a state do not require approval from the Central Environment Ministry. In contrast to legally recorded areas, we have deemed forests. These make up about 1% of India's forest land and are a highly controversial subject. A deemed forest is essentially a tract of land that physically looks like a forest. It has the trees and the ecosystem, but it has never been officially and legally notified as a forest by the state government. This creates complex legal gray areas for conservation and development. Finally, when the FSI actually maps the physical canopy from space, they classify the forest cover into different density categories. As you can see here, very dense forest features a thick, unbroken canopy. Moderately dense forest has tall trees but allows more light through. Open forest is much sparser, with significant gaps between trees. And scrub refers to degraded lands with very poor tree growth, mostly consisting of small bushes. We will explore exactly how these densities are measured next. Moving right along to our next major parameter, let's look at forest cover, or FC. In India's assessment, forest cover has a very specific definition. It includes all patches of land that have a tree canopy density of more than 10% and an area of more than 1 hectare. What's fascinating here is that this classification is completely blind to land use, ownership, or even the species of trees. Whether it's public land, private land, agroforestry, or even a commercial plantation, if it meets the density and area criteria, it counts as forest cover. Forest cover is further divided into 3 distinct classes based on how thick the canopy is. First, we have very dense forest, or VDF, where the tree canopy density is 70% or higher. Next is moderately dense forest, or MDF, with a canopy density between 40 and 70%. Finally, we have open forest, which covers areas with a canopy density between 10 and 40%. It is also important to note that these classifications include mangrove forests as well. When we map these classes across the country, we get a visual representation of India's forest health. The darkest greens represent the very dense forests, primarily found in the Himalayas, the Northeast, and parts of the Western Ghats. The lighter greens show moderately dense and open forests, which are much more widely distributed across central and eastern India. Areas marked as scrub or non-forest fall below that 10%. Now, what about smaller patches of trees? That is where tree cover comes in. Tree cover includes all patches of trees that are smaller than 1 hectare and are located outside the recorded forest area, or RFA. For tree cover, canopy density does not matter at all. When we add forest cover and tree cover together, we get the total forest and tree cover. This combined metric is exactly what the government uses to monitor progress against the National Forest Policy goal, which aims to have 33% of the country's geographical area under forests. Looking at the numbers, the total tree cover of the country is estimated at 95,748 square kilometers, which is a slight increase since the 2019 assessment. If we look at absolute area, Maharashtra leads the pack with over 12,000 square kilometers of tree cover, followed by Rajasthan and Madhya Pradesh. However, if we look at tree cover as a percentage of total geographical area, the Union Territory of Chandigarh takes the top spot at over 13%, followed by Delhi and Kerala. Next, we have a broader category called trees outside forests, or TOF. As the name suggests, this refers to literally all trees located outside the recorded forest area. Unlike tree cover, TOF does not care about patch size or canopy density. The patches could easily be larger than 1 hectare. Because tree cover only includes patches under 1 hectare outside the RFA, tree cover is actually just a subset of the larger TOF category. When we measure trees outside forests, Maharashtra again has the largest extent by absolute area, with nearly 27,000 square kilometers, followed by Odisha. But when we look at the percentage of geographical area covered by TOF, the Union Territory of Lakshadweep is absolutely dominant at a staggering 90%, with Kerala coming in second at 37%. Let's put all these definitions side by side to avoid any confusion. Recorded forest area, or RFA, is simply a legal status. It's any land the government officially notifies as a forest. Forest cover is a physical measurement, patches over 1 hectare with at least 10% canopy density, anywhere in the country. Trees outside forests includes every single tree outside the RFA. And finally, tree cover is the specific portion of TOF where the tree patches are smaller than 1 hectare. This brings us to a crucial conceptual point. A change in forest cover does not mean a change in recorded forest area. While FC and RFA overlap, they are not the same thing. You can have land inside an RFA that has been cleared and has no trees at all. Conversely, you can have a large, dense apple orchard outside the RFA that perfectly meets the criteria for forest cover. Therefore, when we see national forest cover increasing or decreasing, those changes are frequently happening on lands outside the officially recorded forest areas. Let's look at the actual data from the India State of Forest Report, or ISFR 2021, comparing it to 2019. We saw an increase in very dense forest and open forest, but a decrease in moderately dense forest. Overall, the total forest cover increased slightly to 7,113,789 square kilometers, which is 21.71% of India's geographical area. It's also worth noting that the higher quality forests, VDF and MDF combined, make up 57% of the total forest cover. Continuing with the 2021 report, tree cover also saw an upward trend, reaching 2.91% of the geographical area. When we combine forest and tree cover, India sits at 24.62%, still short of the 33% goal, but slowly growing. Scrublands also saw a marginal increase. Consequently, the total non-forest area, which includes water bodies and lands without forest cover, decreased slightly to 76.87% of the country. Zooming out to the global stage, we rely on the Global Forest Resources Assessment, or GFRA. This is published by the UN's Food and Agriculture Organization once every 5 years, with the latest being in 2020. According to this report, between 2010 and 2020, the top 3 countries that recorded the maximum average annual net gains in forest area were China, Australia, and India, with India adding about 0.26 million hectares annually. The GFRA also breaks down where the world's forests are located by a climatic domain. Tropical forests make up the largest share by far, accounting for 45% of global forest area. This is followed by boreal forests in the cold northern latitudes at 27%. Temperate forests make up 16%, and subtropical forests account for the remaining 11%. In terms of total forest area, the Russian Federation holds a massive 20% of the world's forests. They are followed by Brazil, Canada, the United States, and China. India ranks 10th globally, accounting for just 2% of the world's total forest area. Interestingly, countries like Brazil, the Democratic Republic of Congo, and Peru have more than half of their entire geographical area covered by forests. And when it comes to growing stock, the total volume of trees, Brazil actually overtakes Russia for the top spot. The 2020 assessment specifically praised India's Joint Forest Management Program. Thanks to this initiative, forest areas managed by local, tribal, and indigenous communities skyrocketed from 0 in 1990 to about 25 million hectares in 2015. Furthermore, India reported the highest employment in the forestry sector worldwide. Out of the 12.5 million people employed in forestry globally, nearly half of them are in India. We will explore how these local communities manage these resources in the next segment. Let us examine India's mangrove cover. West Bengal is the undisputed leader here, largely due to the Sundarbans. In fact, the South 24 Parganas district in West Bengal alone accounts for nearly 48% of the entire country's mangrove cover. Gujarat and the Andaman and Nicobar Islands follow in second and third place. Still resilience. Moving on to bamboo resources, which are vital for both ecology and local economies. The total bamboo bearing area in India is estimated at 15 million hectares. Madhya Pradesh has the largest share, followed closely by Arunachal Pradesh and Maharashtra. However, unlike mangroves, the total bamboo bearing area has actually decreased by over 1 million hectares compared to the 2019 estimates. While states like Mizoram showed the highest increase, Madhya Pradesh unfortunately recorded the most significant decline. When we talk about climate change, forest carbon stocks are absolutely critical. Globally, forests and their soils store over 1 trillion tons, or 1,000 gigatons of carbon. To put that in perspective, that is roughly 1.3 times larger than all the carbon stored in the world's fossil fuel reserves. Since 1750, forests have absorbed about half of the carbon naturally sequestered from the atmosphere. However, over the last 25 years, global deforestation has caused a concerning decrease in this carbon stock. Zooming into India, the total carbon stock for 2021 is estimated at 7,204 million tons. This represents a slight increase from 2019, translating to a massive 30.1 billion tons of carbon dioxide equivalent sequestered from the atmosphere. If we look at where this carbon is held, tropical dry deciduous forests store the maximum total amount. Geographically, Arunachal Pradesh holds the highest total carbon stock, followed by Madhya Pradesh. It is also important to look at carbon stock density, meaning the amount of carbon stored per hectare. Here, the picture changes. Himalayan dry temperate forests are the most efficient, storing over 244 tons per hectare. Consequently, hilly and mountainous regions like Jammu and Kashmir and Himachal Pradesh lead the states in per hectare carbon storage. Conversely, sparse ecosystems like tropical thorn forests hold the least carbon per hectare. How exactly is this carbon stored? The Intergovernmental Panel on Climate Change identifies 5 main carbon pools in a forest. Above-ground biomass includes the visible trees and plants, while below-ground biomass consists of the live root systems. Then we have dead wood, like fallen logs, and litter, which includes dead leaves. Finally, we have soil organic carbon. Interestingly, soil is actually the largest pool, accounting for 56% of all forest carbon. In northeastern states, soil carbon is almost double the carbon stored in the visible trees above ground. India has made international commitments under the Paris Agreement's Nationally Determined Contributions, or NDCs. The target is to create an additional carbon sink of 2.5 to 3 billion tons of CO2 equivalent by 2030. However, current projections show a shortfall of up to 0.75 billion tons. The most cost-effective strategy to bridge this gap is restoring open forests. Since over 30% of India's tropical forests are currently classified as open, upgrading their density could significantly boost carbon sequestration. Next, we look at growing stock, which is essentially an indicator of a forest's productivity and timber volume. The national average is 56.60 cubic meters per hectare. Kerala, Uttarakhand, and Goa boast the highest growing stock per hectare. However, in terms of absolute total volume, Arunachal Pradesh leads the country. We also measure trees outside forests, or TOF, where Maharashtra has the maximum growing stock, indicating strong agroforestry or urban tree cover. If we break down this growing stock by species, we see a clear divide between natural forests and human-dominated landscapes. Inside recorded forest areas, timber species like sal, teak, and pine contribute the highest volume to the growing stock. On the other hand, for trees outside forests, agricultural and culturally significant trees like mango and neem have the highest growing stocks. A major threat to all these forest resources is fire. More than 36% of India's forest cover is prone to frequent forest fires, with about 10% falling into the very highly or extremely fire-prone categories. To combat this, the Ministry of Environment formulated the National Action Plan on Forest Fires in 2018. A key strategy of this plan is shifting away from purely administrative control and instead empowering forest fringe communities to manage and prevent fires alongside forest departments. Looking at the spatial distribution on this map, you can see that the fire risk is not uniform. The deep red areas, indicating extremely fire-prone zones, are heavily concentrated in the northeastern states. We also see significant orange and red patches across central India, Odisha, and the Himalayan foothills. These regions require targeted monitoring and community intervention during the dry seasons. Now, despite the extensive data provided by the India State of Forest Report, it faces significant criticism from ecologists. The first major issue is the very definition of forest cover. Currently, any commercial plantation, like rubber or palm, that is 1 hectare or more is counted as a forest. This gives a false impression of ecological health. Plantations have shallow roots, cannot retain moisture well, and support very little wildlife. Replacing deep-rooted natural forests with plantations has directly contributed to massive landslides, particularly in the Western Ghats. Another major critique is that the report tends to exaggerate positives while suppressing negatives. When mature forest land is cleared for mining or infrastructure, the government acquires land elsewhere for compensatory afforestation. The ISFR counts these new, ecologically poor saplings as a gain, masking the devastating loss of ancient, carbon-rich forests. Furthermore, the data reveals a paper forest problem. 30% of India's legally recorded forest area actually has absolutely no forest cover on the ground. Finally, the very methodology of data collection is questioned. The ISFR relies heavily on remote sensing satellites that pick up any green on their radar. According to the rules, any land with a tree canopy cover of over 10% is counted as a forest. Satellites cannot easily distinguish between a pristine natural forest, a commercial timber plantation, a mango orchard, or a bamboo grove. Critics argue that the ISFR is essentially measuring green cover rather than mapping true, ecologically functioning forests. That brings us to the end of our comprehensive look at India's forest resources. To wrap up, while India's forest cover is technically increasing on paper, we must remain vigilant about the ecological quality of these areas. Natural forests are irreplaceable carbon sinks and biodiversity hotspots, far superior to commercial plantations. Addressing forest fires, halting the diversion of mature forests, and refining our data collection methods to reflect true ecological health will be absolutely vital for India to meet its climate goals.